Okay, there's one other thing that I want to show you here relative to trig, and kind of having to do with this sine and the sine wave. And this is not in the book or on a test or anything, but I think it's helpful for you to know where some of these things come from, maybe. At least it was for me. So I'm going to make a circle here. Let's kind of clear the deck. That's probably not quite a circle, but let's pretend that it is. Yeah, I know it's not because I missed the line here. Okay, this is going to look like it's off center a little bit, but that's okay. I'm going to draw a line across here like so, and I'm going to draw a line down here like so, and we will pretend that this is at the exact center of the circle. And this is our old friend xy. This circle is imposed upon the Cartesian or coordinate graph system. I'm going to draw one other thing here. I'm going to draw an arbitrary line out here like so. And matter of fact, let's put an arrowhead on this. And this is an x value, this is a y value. But that's not what's important. We know that in a circle, we have 360 degrees. And this is divided into 4 parts. So up here we have 90 degrees. That should come as no surprise because we have a 90-degree angle here. This is at 180 degrees. This is at 270 degrees. And then we're back here to 0 degrees or 360 degrees. They're the same spot. 0 to 359 is 360 degrees. Okay. Now, this is our angle of interest, and if we were to draw a line down from here, and I'll do it as a dashed line, this is the side opposite this angle. This is the side adjacent. This is the side opposite. Okay? And the opposite over the hypotenuse is the sine. Remember, the sine is the opposite over the hypotenuse. Now, picture, if you will, that in the middle of this, there is, I don't want to say a hinge, there's a way to pivot this line. In other words, there's a way to move this line like the hand of a clock around this circle. And notice that if this is 0, we're actually going counterclockwise. We can rotate this arm here, if you will. It's a radius, really. But anyway, we can rotate it counterclockwise, and we can point it to any particular angle we want. And I think you can see how the length of this side opposite and the length of the side adjacent change as we go around this circle. Okay. And this idea, by the way, can be used to identify other trig functions if we make this a so-called unit circle. But that was not my point here. What I want to point out is how a sine wave comes about. So here's our engine for it. So I'm going to replicate it kind of in, and I'll do this freehand, so it's, whoa, stop whatever you're doing here. Okay. My pen decided to go crazy. That's all right. Already been there, done that. So here's our circle. And here's our radius thing going out here. And we have x, y. Now, if we were to plot this, this is just part of the Cartesian graph. The biggest value that a sine can have is 1 and -1. If we were to start at 0, and that's what's right here at this intersection, is 0 degrees. And so we have like 90 degrees, 180 degrees, not 108. Must be dyslexic all of a sudden. Okay, 180 degrees, 270 degrees, and 360 degrees. So this is our y value, this is our x value. If we were to plot this as this thing rotates around, looking at what it does, it creates a sine wave. Now if I could just create a sine wave, there you go. Okay, so pardon my poor drawing skills. We get a sine wave. And of course, as many rotations as this thing goes around, this sine wave goes on. But this is where it comes from. And I thought that that was a really slick idea. And how trig applies to the creation of sine waves. It makes sense since we have the sine. But oftentimes in amateur radio, especially if we're just buying our stuff off the shelf and we're not interested in the theory of radio or whatever, we just kind of take for granted what some of the terms mean. But I like knowing the origin of things to some degree. Okay, don't want to get overloaded in the minutia though, or extraneous details, whatever. So there you have it. There's how a sine wave can be created. And of course we know how to do this electronically in very simple transmitters. Create an oscillator. That's what you're doing. When you're creating an oscillator, you're creating this thing as an engine, and this thing is going around at whatever the speed of the oscillation is. And of course that is the frequency of this. Okay? All right, I think that's enough for this video. Just throwing that in just for FYI. All right, see you in the next video.